We're going to use something called a set of solubility rules to help us determine whether or not something's going to dissolve. And so solubility rules, they're just a very general set of rules or guidelines that help predetermine how a substance will dissolve. We're going to focus on things dissolving in water, and we're going to use our solubility rules to predict whether or not something should dissolve. And that's what we're going to do next. So in this video, we're going to look at solubility rules and how that affects how we write equations or reaction equations, and then use these rules to write net ionic equations. So first we have to go over our solubility rules. Now, I want to tell you, you do not have to have these memorized for this class. If you want to memorize them, great. While practicing, you probably will start to memorize some of them. However, you will not have to know all of these rules by heart. So that being said, you will want them in your notes so you can use them, because that's really what we want to see. We want to see you be able to use and apply the rules rather than just memorize the rules. So there are 5 of them, so let's go through them. First, all salts of group 1 elements and ammonium ions are soluble. Now, when we say soluble, that means it dissolves in water. That's really what we're looking at, is solubility in water. You can look at solubility in other things, but we're going to focus on solubility in water. So that means that all ionic compounds that have any group 1 elements, so that's lithium, sodium, potassium, rubidium, cesium, and francium, although you're probably not going to see francium, any of those ionic compounds are going to dissolve. So they're going to be soluble. Our second rule is that all acetates and all nitrates are soluble. So acetate and nitrate are 2 of our polyatomic ions. Anything that's an acetate or a nitrate is going to dissolve. Number 3, all ionic compounds with group 17 elements are soluble. So those, with the exception of fluorine sometimes. So that's primarily our chlorides, our bromides, and our iodides. So anything that's chloride, bromide, iodine is going to dissolve, except for silver, mercury, and lead. Those are our 3 exceptions. So for example, silver chloride isn't going to dissolve because that's an exception to this rule. Number 4, all sulfates are soluble, except, and this actually has a fairly long exceptions list, except barium sulfate, strontium sulfate, lead sulfate, calcium sulfate, and mercury sulfate. So those are the exceptions, but anything else that's a sulfate compound is going to be soluble, or it's going to dissolve. And then rule 5 is our insoluble ones. All carbonates, hydroxides, sulfides, and phosphates are insoluble. Insoluble means it's not going to dissolve, except for those in group 1. So for example, sodium carbonate, because sodium is a group 1 element, sodium carbonate is actually going to dissolve. So I'm just going to go through here really quick. So rules 1, 2, 3, and 4 talk about our solubility, which ones are soluble, except don't forget the exceptions. And then our rule number 5, those are insoluble, and then our exceptions are group 1s. So keeping these in mind, we're going to walk through 2 practices. So here we have an example of what one of these problems might look like. So sodium hydroxide is reacting with copper 2 chloride to produce we don't know what. So the first thing is we have to figure out what might possibly be produced from this reaction. So we're going to divide each of these up into its positives and its negatives. So our sodium is sodium plus 1, our hydroxide is hydroxide minus 1, our copper is copper plus 2, because there's the 2 down here, and our chlorine is our chloride minus 1 ion. And so when we write the products, the first thing that we're going to do is we're going to swap our positives. And so, because we can never have a positive bond with a positive or a negative bond with a negative. So basically they're just going to swap partners. So our sodium is going to bond with our chlorine to form sodium chloride. And then our copper plus 2 is going to bond with our hydroxide to form copper 2 hydroxide, so Cu OH2. And then if we wanted to balance this, we need 2 sodium hydroxides and 2 sodium chlorides for this to balance. Now, if we're writing a net ionic equation, we need to look at our solubility rules. We need to decide what is actually going to precipitate out or what's actually going to form a solid. Because if both of these can dissolve in water, then we say that no reaction takes place because we're not actually going to see anything occur. Everything's just going to divide back up and stay as its ions. So I know based on my rules that sodium chloride is going to dissolve. And so if it's going to dissolve, we put a little AQ symbol. That means aqueous. And then if I look at my rules tell me, and sorry, I put my board down here, that rule 5 says all hydroxides are insoluble except group 1. So this should be insoluble. Copper is not in group 1, so this is not going to dissolve, which means it's going to be a solid. Now, since sodium chloride is going to dissolve back into solution, it's not really going to do anything. So the only thing that we're going to see actually be formed is our copper 2 hydroxide. So when we go to write our net ionic equation, we only include the reactants that form this. So the only things that form our copper 2 hydroxide are hydroxide ion and our copper ion. And then to balance it, we're going to need 2 hydroxides. So this right here is called our net ionic equation. Now you might be asking, well, what about our sodium and our chloride? Well, those are considered spectator ions. So we're going to say that our spectator ions are sodium and our chloride ions. And by spectator ions, that just means that they're not participating in the reaction. They don't do anything. They start as sodium and chlorine at the beginning and they stay as separate sodium and chlorine at the end. So this right here would be our net ionic equation. So let's work through another example. Okay, so in this one I have barium nitrate and sodium carbonate. And so the first thing I'm going to do is predict what the products are going to be. And I'm not worrying about solubility rules right now. I'm just looking at swapping my positives. So my barium has a +2 charge. My nitrate has a -1 charge. Sodium has a +1 charge. And carbonate has a -2 charge. So those are my ions that I have going on. Now our positives are going to switch. So we're going to form sodium nitrate. So NaNO3. And barium carbonate. Since barium and carbonate have the same charges, it's just going to be BaCO3. Now, we're going to use our rules again to figure out what's going to go on with these. Now, our second solubility rule says that all nitrates are soluble. So this guy is going to dissolve, and it's not going to form a solid. So let's check and see about our barium carbonate. Now, our fifth rule says that all carbonates are insoluble except for group 1. So the question you should be asking is barium in group 1? No, barium's in group 2. So this is insoluble, which means it's going to form a solid. So if I wanted to write my net ionic equation, I know that my only product is going to be my barium carbonate. Oops. And to form that, I needed my barium ion and, +2, and my carbonate ion. Which means my spectator ions are going to be the other pieces. So sodium is a spectator ion and nitrate is a spectator ion. So the whole purpose of this is to use and apply those solubility rules to predict what we would actually see. So if we were actually doing this reaction, we would dissolve these two together, put them in the same beaker, the same test tube. And what we would see is a precipitate or a solid form, and that solid would be barium carbonate.